And we can calculate the electric field at the center of the tetrahedron. You can expect there will be very much geometry, symmetry, and lots of twists in mind. But you will see nothing is going to happen, and you can solve this problem in with ease and in simplest manner. Let's read the statement of the problem that says one face of a regular tetrahedron. Charge is uniformly distributed with surface charge density sigma 1. So let me put it here. And on other three faces with the surface charge density sigma 3 and one hidden one sigma 3. Find the electric field modulus E2 at the tetrahedron center of the tetrahedron. We need to find out the electric field, magnitude of electric field. And we know that the closed surface of the tetrahedron subtends a solid angle of 4 pi at its center. So any of the surfaces of the tetrahedron is going to subtend a solid angle of 4 pi by 4 at its center. 1 by 4th, 1 quarter of the net solid angle at its center. And so we can also write, as we did in the previous problem, electric field at the center due to this surface charge density sigma 1 is going to be k sigma 1 multiplied by the solid angle 4 pi by 4, and if I put the value of k as 1 by 4 pi epsilon naught, then this result will be simply as sigma 1 by 4 epsilon naught, sigma 1 by 4 epsilon naught only, just epsilon naught. Yeah, this is the result. And I'm not going to directly calculate the electric field due to all three sigma 3 charge distributions, because I simply know that if the other three faces had the same surface charge density sigma 1, then they together created the same field in the center, this one, but in opposite direction, because the total field should be 0 in this case. So keeping in mind that if the other three surfaces had the same surface charge density sigma 1, then they would have created the same magnetic field in the center as sigma 1 by 4 epsilon naught, but in opposite direction, so that the electric field at the center becomes 0. So the actual electric field of these three surfaces can be found from proportionality of the charge strength. And the charge strength, because E is directly proportional to sigma, electric field is directly proportional to sigma, I can write the three surfaces of charge density sigma 3 will together behave like a charge density of sigma 3, and they can produce the electric field E3, not E2, as E3 must be, E is directly proportional to sigma. That means E3 will be sigma 3 by sigma 1 multiplied by E1, and put the value of E1 from here and you will get the results will be sigma 3 by 4 epsilon naught. So from the superposition of electric field, we know that the required electric field E2 must be E1 minus E3, and the result you are going to get, the magnitude in general, you are going to get simply as sigma 1 minus sigma 3 by 4 epsilon naught, and that's the result. Thank you very much for watching.